Assalamualaikum. Our group consists of 4 members, including me, Alif, Hafiz, Nabil, and Fahmi. And we are going to present question number 3 for assignment 3 SOA. Okay, so I'm going to read the question. A fund earning 8% effective is being accumulated with payment of 500 at the beginning of each year for 20 years straight. Find the maximum number of withdrawals of 1,000 that can be made at the end of years under the condition that once withdrawals start, they must continue through the end of the 20-year period. So based on the question, we can extract the information. We know that this is the annuity due because of the question state 500 at the beginning of each year. So the first information that we obtain is I, which is 8%, R 500, and 20, and withdrawal is 1,000.
To have a better understanding, we need to draw a time diagram based on the information given in the question. We are told that $500 is deposited at the beginning of each year for 20 years into a fund earning 8% effective annual interest. Let's draw a timeline from year 0 to year 20. Each R at the beginning of the year represents a deposit of $500. The first deposit is at year 0 and the last is at year 19. That's 20 deposits in total. Now, starting from some unknown year, the fund begins making withdrawals of $1,000 at the end of each year, continuing all the way to year 20. Here, the downward arrows starting at year end show the withdrawals of $1,000 made at the end of each year. As the question said that once withdrawals start, they must continue every year until year 20. So, the goal is to find the maximum number of $1,000 withdrawals we can make, which means we want to start withdrawing as early as possible, but only when there's enough money in the fund to support. We need to ensure that the value of the accumulated value at year end is enough to support withdrawals of $1,000.
Hi, in this video, I will show you how to calculate the future value of saving $500 every year for 20 years with an interest rate of 8% per year. Since the payments are made at the beginning of each year, this is called an annuity due. The general formula for the future value of an annuity due is FV RS double dot angle N, where S double dot angle N is 1 plus I power of n minus 1 over d. First, we need to find d, which is d is equals I over 1 plus I, where I is 0.08. So we got d equals to 0.0740740747. Then we can find the future value for each year. Here are the list of future value for T1 to T20, where the final future value is 24711.46.
Alright, after we get FV equals to 24,711, so next we need to find the maximum number of withdrawals of $1,000 that can be made at the end of years, and under the condition that once withdrawals start, they must continue through the end of 20 years period. So here the keyword is the payment is made at the end of years, so it is immediate, annuity immediate. Okay, so here I'm use the formula that 1,000 A angle N times with 1.08 power of n equals to our future value. Why? Because the payment is made before and our common date is at 20 that our future value get. So here why we need to that's why we need to times with 1.08 power of n, and n is we don't know, so here we can find the maximum n, maximum withdrawal that can we get. So after input all of the information, so we get 1,000 times with 1 minus 1.08 power of negative n over 0.08 times with 1.08 power of n equals to 24,711.46072, and we get n equals to 14.1746. So here we equal to n will be equal to 14. So the maximum number that withdrawals can be made is 14.
Okay, so in order to check whether the 14 is true or not, we have to substitute it back into the equation before. So we get that N14, and the maximum money that we can withdraw is 24,211. The money that we can withdraw is less than 24,700. So it is true that 14 is the maximum number that we can withdraw. Okay.